A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the course NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Today's lecture is the second lecture of Module 1 of this particular course, which will have the discussion on pavement types and their cross-sectional elements. So, in this particular lecture of today's, we will be discussing about some of the key features of pavements and their cross-sectional elements. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Pavement and their types. When it comes to pavement, one question all of the sudden can come to any of one of our mind, that why do we need pavement? We can, so the pavement is basically any surface which can give you a smooth, and nowadays again the important requirement is safe ride. So, if you are able to get a safe and smooth ride by any kind of surface, it is good enough for you. So, if the natural soil is there or natural ground is there, if I am going to ply my vehicles over that particular one, we will be able to find situations of this kind. So, this particular one, when the traffic loads will come up over the existing natural ground, then this will get excessively deformed, and under different climatic conditions the situations may become more worse. If it is rainy, then you might have found a good amount of water getting accumulated. This will further create the reduction of the strength of the soil, and the traction forces will be more. So, you cannot drive your vehicles on this kind of surface. So, what do you need? You need an engineered structure. So, that is why we call that what are pavements. A pavement is an engineered structure that provides smooth and safe. So, this is from the user perspective. I will say I require two things. I required one surface to be smooth, and the second surface should be safe. Now, the safety is also becoming important concern, not only the smoothness. So, the user perspective says give me an engineered structure, and because if I do not go for an engineered structure, then the situation, as I explained, this is an unengineered structure where nothing good has been done, only the natural ground has been made available for the movement of the traffic. Then from the engineering perspective, one important aspect is it should have adequate stability. So, that says that the structure should be, that engineered structure is to be stable enough for the movement of vehicles and pedestrians, vehicles, different kind of vehicles, and this should give the desired performance under different climatic conditions. This is another important thing. So, that is why we call a pavement as an engineered structure that provides a smooth, safe and stable platform for the movement of vehicles, and vehicles, different type of vehicles, two-wheelers, four-wheelers, heavy vehicles, and the movement of pedestrians also. As I mentioned, a pavement crust is needed, since in most of the cases the existing, if there is very low traffic, only some animal drawn vehicles are there, then the existing natural ground soil can work in some cases with a little bit amount of stabilization. So, then it can serve the purpose. Otherwise, in most of the cases it is not able, because nowadays all areas are are having good amount of movement of vehicles. So, existing soil layer is not capable of supporting the loads of commonly used vehicles. Now, if I do not go without this kind of structure, I will call it as pavement crust, because whatever which is there inside that pavement is my crust. So, that pavement crust is not there, then the natural soil will get deformed excessively and hinder the movement of vehicular traffic for a desired level of speed also. This is also very important. If I am going from one place to the other, I want to know how much time it will take. So, that will depend upon at what speed I will be moving over that particular surface. So, the speed is also a concern, and then my journey should be safe enough. So, the engineered structures which are constructed for this particular purpose are three main structures. The most commonly used structure is your flexible payment structure. Then we have rigid payment structure, and then a combination of which is sometimes used, not very common, where some of the characteristics of flexible payments and rigid payments, to meet out some specific requirements, composite payments are constructed. Otherwise, if you say what two main broad categories, flexible payments and rigid payments. Now, let us come into more depth, what is a flexible payment and what is a rigid payment. I am trying to cover these things in a brief manner because we need to discuss many more things in the upcoming lectures of different modules. So, I will try to give you a glimpse of the information from the construction perspective. Now, one you see a left hand side is a composition which is shown for a flexible payment. Here you can see I mentioned here, if there is an existing natural soil, I mentioned it existing natural soil or ground layer. So, if it is a plain terrain, then existing soil or ground layer is there. I will create a crust over it. What that crust will be there? Before that, I will make a subgrade, and this subgrade will be of selected soil. And this selected soil may be the existing nearby soil also, or a soil which may be collected from some borrow area, or a soil which is existing but stabilized through some method. So, that forms your subgrade course. This is your subgrade course. So, this is made of soil. Then comes your payment crust. Your payment crust is whatever which you have above the subgrade. More features of subgrade, definitely in upcoming lectures we will have a complete discussion on subgrade construction also. So, more features will be discussed there. Followed by what you have, two courses are shown here, subbase course and base courses. Now, these are granular courses and granular unbound courses, no binding material most of the time used in these courses. This what I am talking about is a conventional composition of a flexible payment. We have different combinations nowadays, where depending upon the climatic requirements, traffic loading requirements, the different combinations are constructed. But the conventional one says you have a subgrade course, natural soil subgrade course, over which your payment crust comes, which consists of a granular subbase course. Now, here also there is a further bifurcation in terms of a separation layer is there, a drainage layer is there. Those aspects I will discuss in upcoming one. Then you have a base course. Base course also conventionally used as an unbound base course. So, these are granular courses without any binding material. Now, in flexible payment, the binding material which is most popular or the most commonly used material is your bitumen. Bitumen is a product, is a hydrocarbon which is produced nowadays from the one which is used most commonly is produced from the distillation of your crude. Now, you get different fractions, you might have read about it, that from the destructive distillation or fractional distillation, there are different ways in which you can extract different products. So, from the distillation of crude, where we get diesel, petrol, other products, the one residuum which you get is your bitumen. Now, bitumen is used as a binding material in these courses. You have your binder course and you have a wearing course. Because of this binding material, they have a good strength compared to your unbound courses. Now, the other part is mentioned. So, whenever a flexible payment structure is mentioned, it is said that is a type of payment structure that primarily relies on the flexibility. That means it is less rigid, the flexure strength is less compared to what is there in the other. This is a comparative statement compared to what you have in the rigid payments. And since one layer is resting over the other, we very commonly says that the load transfer mechanism is through the grain to grain transfer, and one layer is resting over the other layer. So, this is a typical composition and construction pattern of a flexible payments. This entire course is on payment construction technology. So, all these things we will be discussing. I just want in this particular lecture to give a feel how a payment is, what a payment is. Then in upcoming lectures further details will be discussed with you all. Now, this flexible pavement is to be designed as per Indian Roads Codal Guidelines, which is IRC 37 2018. Now, it helps you to figure out what should be the crust, what should be the thickness of the individual layers in this particular one. We will have a brief comparison between these two most commonly pavements, flexible and rigid pavements. Flexible pavement is very popular. More than 90% of the roads, not in India, throughout the globe, are flexible pavements. And how it looks like, if I have a cross section of a flexible pavement, this is what a cross section is shown here. Now, here you can see there is a natural soil subgrade layer which is there. Over this particular one, I will select a soil which can be an existing soil, but the characteristics are to be controlled characteristics. So, I will select a soil with a some desired characteristics, and I will construct this subgrade course. Over this particular one, I have to construct few layers, and that forms my pavement crust. The conventional flexible pavement consists of few granular courses and few bound courses. The granular courses are unbound courses. Two normally used, conventionally used granular courses are your sub-base course and a base course. They serve different functions that we will discuss in the upcoming lectures. And so, they do not have any binding material. When you go up, you have your binder courses, you have your wearing course or surface course. They are constructed using aggregates with some binding material, and in flexible pavements the binding material is used as bitumen. It is also called as asphalt, or also a synonym as asphalt binder. Now, these layers are quite flexural. They have a less flexural strength compared to, this is a comparison which is made with the rigid pavements. So, it says is a type of pavement structure that primarily relies on the flexibility and grain to grain transfer. For these layers rest over each other, they does not have a very high flexural strength, unbound materials are there. So, the load transfer mechanism is through grain to grain transfer, and they are resting over each other. Now, for this particular one, Indian Roads Congress has given guidelines IRC 37. IRC 37 helps you to work out the crust composition of a flexible pavement and see whether this is good enough for a given design traffic or a good amount for the existing traffic loading situations. Now, the other one which is common is your rigid pavements. Now, as the word itself says, this is a rigid structure. So, it has a more flexural strength or more flexural rigidity compared to your flexible pavements. Now, here also you see we have a natural soil subgrade. This is when it is we are constructing plain areas. If you are constructing in some cut areas or where you require to raise the, because there may be the waterlogging may be a concern. So, you may require to raise the level of your road surface. So, you will construct an embankment also over the natural ground before you construct your subgrade course. Now, subgrade is again a controlled one where you have the soil characteristics control. It can be your existing soil can be suitable enough to construct a subgrade, or you may have to select a borrow area, or you may have to stabilize the existing soil to construct your subgrade course. What comes over this particular one is either an unbound layer, which is again a granular course, followed by a base course which is a bounded course, and then on the top we have a cement concrete slab. Now, this cement concrete slab have a good strength. So, that is why this becomes a rigid pavement structure. Rigid pavement is a pavement structure that primarily uses cement concrete as a surface course. Flexural rigidity is quite high, and this, since its flexural rigidity is high, it distributes the load over a wider area compared to what is there, because there it makes a transfer through the aggregates contacts, or what we say as grain to grain transfer. Now, few more differences between this particular one. As I mentioned, one is it has a lower flexural strength. You can see this is again a composition which is shown here. You have the subgrade course with you constructed with a natural with a selected soil, it can be natural or a stabilized or a bore area soil. And what you have over this particular one is your pavement crust. Now, in this pavement crust, you have granular courses which consist of more than 3-4, because you have granular sub-base course also, which is just over, and followed by the base courses. All information will in upcoming lectures we will further discuss about this subgrade, granular sub-base course, followed by a granular base course. Then we have bituminous bound course, and on the top we have a wearing course. Now, since this is a bituminous bound material is there, you can see bitumen is black in color. So, the color difference is there. You can see the aggregate pieces. This is a granular course. The granular course serves different purposes, bound course serves different purposes, and but they does not have these layers are resting, they does not have high flux strength, they rest over each other. So, if there is some major deformation happening in say your granular course, the upper layer will also resting over it will get deformed, and in due course of time that deformation can get reflected on the top of your pavement course. Thus, if the lower layer of the pavement or soil subgrade is undulated or deformed excessively, the flexible pavement surface also gets deformed in near future. This is on the right hand side of the slide, it shows rigid pavements which poses high flux strength or high rigidity in that case. Now, in this case you can see again the IRC codal specifications which is used or referred for this rigid pavement is IRC 58. There are many more, but the one dedicatedly for the design of this particular one is IRC 58. There are some internal components for which you need to refer some more IRC codes or BIS, Bureau of Indian Standards codes. Now, it says you need to have a high quality cement concrete mix as a surface course, or we can call it as a wearing course, followed by, since there in this particular one you need to have again a good base which is normally constructed with your dryline concrete, or here I am saying as a cement treated aggregates. At the bottom again you can see this is a subgrade, again this is a subgrade with a selected soil. Now, there is always a requirement, whatever type of pavement structure is there, we need to provide some drainage layer. So, the purpose of the drainage layer again we will discuss in upcoming layers. Drainage is a very important aspect for any kind of pavement structure. So, and this is a drainage which is within the pavement structure. So, you need to have the drainage course. Now, here you can see GSB one is a separation layer, so as to separate the soil material from the granular material, and then there is a drainage course which is there. So, these are two, followed by a stabilized or a bounded course which is in terms of dryline concrete. Now, these two, because we know that cement concrete will expand at higher temperatures, contract during winters at lower temperatures. So, this expansion and contraction should not be restricted. So, it says a debonding layer is to be provided. So, there is a debonding layer provided in between this particular one. This debonding layer may be of a polythene sheet, or in some cases a bituminous layer is used as a debonding. When bituminous layer is used as a debonding, then one aspect is there, you have to whitewash this particular bituminous and bituminous surface, because bitumen is a black material, it has a tendency to absorb heat. So, that since it will absorb heat, it will become hotter, and this will create a disadvantage to the concrete slab which is over it. So, this is a general bifurcation between the two. Now, let us see how a pavement structure looks like from different aspects. One we discussed just now was in terms of the cross section elements. Here also those cross section elements are shown, subgrade. These figures are drawn not up through the scale, but just to give some idea to it. So, there may be, you might not be, I will show some real pictures also. This is the main aim is here to give you an explanation what these layers are, but this you may not be having these all to the exact dimensions. So, a subgrade course is there, you have a sub-base course, which may be a granular course, a base course may be there, and on the top you have the bituminous courses are there. So, how it looks for you as a user from the top, you have this black top surface for flexible pavements which have a slope also. So, here you can say I have mentioned that they have a slope here, and we call this cross slope or the slope as the camber. Now, and in some cases you might have find there is a space between the two directions of the traffic which is moving. So, this particular space is known as median. Now, where the actual traffic moves, that particular part is known as carriageway. So, this is carriageway. Then you have the medians, and if it is an urban section, you might have seen there are curb stones are also placed. These are small concrete structures to separate the movement or to protect the edges. So, these are curb stones. Now, so there and here you can see these are shoulders. Shoulders are again of different types. We will see in upcoming slides what are there. So, then comes the shoulder. So, the width, which is your shoulder, which is your carriageway, which includes your median on both the sides, becomes your roadway width. Now, this width is there. So, you have shoulders. Thereafter shoulders, there will be some side slopes. The water will come out. There will be openings in the curb stones, it will come on the shoulders, then with these side slopes, it needs to get collected into your side drains. You need to have some spaces for utility also, utility corridors for various utilities which has to be provided along the roadside. So, you will have some utility. So, this gives you how much land you require for a particular road surface. So, if what is my carriageway width which I have to provide, median width, shoulder width, and the road margins which I have to. So, this is road. This road margin plus roadway width on both the sides become your right of way, and which is very commonly referred as ROW. So, for different type of categories of roads, we have different requirements of ROW. Whenever a new project starts, land acquisition starts, this term always comes into picture. What is the ROW? What is the right of way which is required for constructing this particular road? In addition to this particular one, two terms have been mentioned here, building line and control line. Building line, normally it is always restricted that there should be no construction within this particular range, because this keeps us a scope for future expansion, and other thing is that it many a times creates a safety hazard. So, we put up that up to the building line there should be no construction which should be present there, and from the building line to control line there should be some particular structures which should be only allowed. So, that gives you the control line. So, these are normally the terms which are used. So, our right of way is the area of land acquired for the road purpose. Now, I will show some typical cross sections, how it looks like. Now, see, this is typical cross sections. I am trying to show the surface features, not the composition of it. So, here you can see the first one is a typical cross section of a two-lane highway. This is again a description which have been recreated using the reference of IRC SP 73 2018, which is manual of specifications and standards for two laning of highways with paved shoulder. Now, here you say this particular one is a two-lane highway. Two-lane conventionally, one common terminology is what is a lane width. For most of the cases, the lane width is taken as 3.5. I will discuss this one also in a coming slide. But if one lane is equals to 3.5, two lanes will be having a width of 7 meter. So, this is the middle of my lane of this carriageway, then one lane on this side, one lane on this side. This is a two-lane carriageway. So, this you might have, many of you might have travelled on this kind of surface. Then you have a paved shoulder. Here it is given that paved shoulder should be of a width of 2.5 on both the side. Then you have an earthen shoulder. Paved shoulder, from the top it appears to be the same surface. What the surface of your the main carriageway is the surface of your, only a small difference may be there in the composition, only a small difference I am seeing. especially in the bounded layers. So, otherwise from the top you will find in most of the cases even the composition remains same for the paved shoulders. So, from top only the markings which are there, here I am trying to indicate you the markings. So, from the markings you are able to work out this is your paved shoulder, and then earthen shoulders may also be there. Then you can see again the side slopes are there, you have the earthen drains, and you may require utility corridors for your electric lines and for other cables, all those things. So, ultimately it says that this should be your right of way. So, this is now for if I should be able to know if I want to construct a 2-lane highway as per IRC, because everything has to be done as per some standard. So, as per IRC SP 73 guidelines, then what land should be available with me, this is important. So, this is how it is. Now, see, this is for a, there are different types of highway. This is a 4-lane divided highway without service roads. Now, this is another feature. You might have travelled on various roads where there is one main carriageway, then there is something which separates the main carriageway, and then you have some side roads which are also known as service roads. Here you can see again there is a part, there is an island or there is a raised portion which we call as median. We will discuss this again. So, medians are there which separates the two direction of traffic. Here there was nothing. What this raised portion, I just wanted to give an information, there was nothing raised here actually, but here this is actually raised. This, so there is a raised land in between which we call as median, and this particular median width already given that it says a median width has to be there of around 4 meter, and then it says there are curb shines. Normally I will explain in upcoming slides when curbs are there, because the edges of these medians, these are imaginary lines which are created so that vehicles do not hit the median curbs. So, that is why this is curb shines we call them, that this is an imaginary half a meter distance which is created near the medians in that case. So, if I have a 4-lane, then 2 lanes are there in this way and 2 lanes are there on this side. 5 meter median is there. Then we have the paved shoulders of 2.5, we have earthen shoulders of 1.5. So, this makes, so if you see what is your in this particular way, what is your roadway width? Roadway width is your 27 meter, and then what drains are there, when utility spaces are there, this total makes your right of way. Now, in this particular one there is no service road. Now, what is service road, how it looks like? This figure shows how a service road, when there is a presence of service road, how it looks like. So, the middle part is more or less same. You can see the again the 27 meter of roadway width is there. After the earthen shoulders, there is a space for your drains, and then followed by again some earthen shoulders are there, and then you can see again a carriageway is there. This carriageway is of 7 meter. So, that it is a 2-lane, normally service roads are constructed with 2 lanes. This is a conventional practice, there are exceptional cases always there. And then earthen shoulder on this particular size, and this is again the spaces for your utilities. So, here what is happening for any local traffic, if I want that to separate out the local traffic from my main carriageway, so that through traffic is not disturbed, for my local traffic I will prefer to give these service roads. This is what is here. So, again this is given as per IRC 84 2019. Now, as I said, you should be aware how much right of way is required for you, because this is the beginning part, and this land which you make available, because normally you design your structures for a life of say 20 years, 30 years, and in due course of time there may be a requirement after certain years you might feel to widen those particular existing roads. There then again if the road development comes up, the land acquisition becomes very difficult. You want to have some more features, safety features, then this so there in this particular case it is very important to acquire the right or the required amount of right of way for any, and to control and to make that available throughout the life of the road. So, a right of way, it should not be encroached that once you acquired in the beginning and later on after a few years people encroached it, so your entire purpose is lost. A right of way is the land acquired for road construction purposes and the provision of utilities along the length, because later on if you find that there are more rains, collection of drainage system have to be good enough. So, all these are to be utility corridors have to come up, then all these needs to be done in the right of way only. A minimum right of way must be applicable for the development of highways and expressways, while a desirable land width should be provided. This is desirable, that okay, this much is definitely we can keep in that case to accommodate potential future upgrades. Now, let us see what the road classification says about the different right of way. It says if I construct 2-lane, 4-lane, 6-lane, 8-lane highways, then what should be the minimum ROW? Right of way. It says in case of 2-lane 30 meter, 4-lane 45 meter, 6-lane 60 meter, 8-lane 120 meter. And when it comes for expressways, it says at least 90 to 120 meters of right of way should be there. Again, for other categories, as we discussed in the previous lecture about the other classes of roads, major district roads, ODR, other district roads and village district roads, there also again for different terrains, like for plain and rolling terrains, it is easy to acquire more amount of land or to get more land ready for the road construction purposes in plain and rolling terrain compared to what you have in mountainous and steep terrain. So, here you can see for a normal what is the requirement for a major district road. For a normal, it says that you can go for 25 and the range should be 25 to 30. If this is for open area, if there is some built up area, means there is some construction habitation is there, then it can be slightly reduced. So, these are given, these requirements are given under our IRC codal provisions. Now, these key features we will discuss in a bit more detail here. So, the carriageway was the one term which we discussed, that the carriageway is the surface over which the vehicle moves. So, a carriageway denotes a stretch of road where vehicles can maneuver laterally without encountering any physical barriers. So, this is here in this case you can see this width is available for the vehicles to move. They say there is a marking. So, half of the width is available for this direction of vehicle, half of the width is available for this direction of traffic. Here you can see a term is used, dual carriageway. Dual carriageway means the two directions of traffic are separated. So, how it is separated? It is separated by median, which can be a raised median or it can be depressed median. When I will discuss about median, I will discuss about this. So, here you can see this is another carriageway on this side, this is a carriageway on this particular side. So, a carriageway provides dedicated space for motorized vehicles separated from walking, cycling and stationary activities, because it is for maneuverability for the vehicles. Typically, carriageways are located in the middle of the right of way of the road, because right of way is there, we acquire the land and in the middle of that right of way you have your main carriageways. The primary purpose of a carriageway is the vehicle mobility, because that surface is so different type of surfaces depending upon different pavement structures, like flexible pavements. You see all these are flexible pavements. So, you have the blacktop surfaces appearing here. Now, carriageway width, again the carriageway width, as I said, depending we said 2-lane highway, 4-lane dual carriageway, like this way 2-lane dual carriageway. So, these are the terms we need to understand when we say 2-lane, what it means. So, it says recommended carriageway width for urban roads. Urban roads are specified as per IRC codal specification IRC 86, which says single lane without curbs. If there are no curbs on the side, only one lane is to be there, that the width is 3.5 meter. 2-lane with raised curbs. So, if it is passing where you are requiring to put up some curbs on the pavement edges, then it says 7 meter width. 4-lane width with or without curbs 14 meters, 6-lane with raised curbs 21 meters, 8-lane without curbs 28 meter. Now, one important aspect which we normally see from the rural highways which are constructed in rural highways, especially national highways, expressways or state highways, which follows the guidelines of IRC 73. It says that if a single lane is to be constructed, the width should be, a single lane width per lane should be 3.75 meter. And if multi-lane pavements are to be constructed under state highways, national highways, then if more than one lanes are there, each lane should be having a width of 3.5 meter. If multi-lane expressways are there, where the speeds are quite high, design speeds are more than 120 km per hour, they says that the lane width is 3.75 meter. So, if I need to have 2 lanes, then it is 3.75 into 2. If I need to have 3 lanes in one direction, it will be 3.75 into 3. So, this is how. For access roads to residential, a lower lane width, this is for urban sections. If there are certain limitations, restrictions, then you can reduce this 3.5 to 3 meter. Minimum width of urban road without curb shall be, if I need to construct any urban road without any provision of curbs, then I can go for, at least I should provide a width of 5.5 meter. Now, this is the second terminology. So, with this particular one, in this lecture discussion we will complete here, and in next lecture we will again follow up with the key features of the pavement sections. Thank you.